Hello, Precalculus student. This video is for Chapter 3. The first part of Chapter 3 is 3.1, Complex Numbers. In real numbers, what we have been studying, we have rational numbers, we have irrational numbers, like those square root, 2 that are non-perfect root, or even cube root or fourth root. So in general, in real number, we have these two big types. Now we are running into another types of number called complex number. Where does complex number come from? You must notice that when we do chapter 1, we have been always talking about, if you do a function, a real value functions, usually when we say a function is a real value, right? So we say, if I have a function like f of x equal to square root x, something like that, the inside of the square root function must be non-negative because we cannot, so the domain of this function has to be x has to be greater than or equal to 0, right? Anything inside has to be non-negative because we just cannot do a negative square root because they do not give any number that exists in the real number system. So we are trying to break through this restriction by announcing that let's try to do it. Let's try to do a square root of a negative number by assigning a symbol called I to square root of -1. Now, square root of -1 does not exist. It's something that is imaginary, so we call it an imaginary unit. I is called an imaginary unit. Its value is the square root of -1, but this is not exactly its value. You have to add the fact that the properties of this I is when you square it is actually equal to -1, right? So remember the way we define this imaginary unit is I is square root of -1, but actually I square is -1. So you don't use the principle of radical that say that, okay, I squared is square root of -1 times square root of -1, it become 1. So that is not true. So these are the two definition of I, not just one. Okay. And then a complex number would be forming the I with a real number as like a sum. So you can form a number with a real part, just 5 or -2 or 3.2, add the imaginary part, and this combined together with the real part and the imaginary part, where b is also a real number, is called a complex number. Okay, so and this is called a standard form of complex number. All complex number can be written in this form. So how do I write square root of -25 as a complex number? So I don't have to define another imaginary unit for -25. This is good enough for us because anytime you have a negative inside radical, you would write the positive in the front and write -1 at the back because radicals this, the rule of radical is if you can write it as -1 times 25, you can split it into this. So the front will become a 5, right? Or it's a real number. And then square root of -1, you can write I. So anytime you have negative something in a radical, you can write it in terms of I. Okay, so in this particular case, 25 is a perfect square, so you have 5i. In case it's not a perfect square, you can just do a radical. Okay, so another example, I have a number is 3 minus 2 square root of -16. Square root of -16 is not a perfect square. As a matter of fact, it's a negative square root. So I would split a I out, right? So I would do 2 square root of 16 times square root of -1. This is the imaginary unit I. Square root of 16 is 4. So I would do 3 minus 2 times 4, I. So that is 3 minus 8i. The real part cannot combine with anything in the imaginary part. Okay, kind of like unlike terms. So this is a constant term, this is the imaginary term, or the real term and the imaginary part. The whole thing is called a complex number. The third example is I divide this complex number by 3. So how can I write it as a plus bi? Because we say complex number has to be two part, real part and imaginary part. So let's see. I see a -9, so I know under the square root, I know this is a complex number. So I simplify the top as 3 minus 2 times square root 9, and then the square root of negative 1, which become I, right? And then I still divide by 3 first. So the top would become 3 minus 2 times 3, right? So this is 3. Square root of 9 is 3 times 6I over 3. And then I split them into 2. So 3 over 3 is 1. 6 over 3 is I. So I end up having a complex number 1 minus 2I. So these are all cooked up, so they divide totally. If it doesn't divide, you just have a fraction. A fraction is still a real number. So anytime you have in a number sentence where you have a square root of a negative number, you can simplify it as a complex number with a real part and an imaginary part. So how do we imagine a complex number? In the old day, if I have a number line, right? So 0, 1, 2, -1, -2. Remember the number line? We say we can graph x greater than 2 or x equal to 1, like dots like that. So, but this is the real number line, right? Real number line. You can only graph real number. So you can graph -2 over here. But you cannot graph 3i. So if you graph this number, -2 plus 3i, it does not represent it totally. So how can I graph a number on a real number line? You cannot. So what we can do is we add a vertical line. Now this is not the y-axis and the x-axis. This is not the x-axis. It's actually a real number line that we used to do when we do inequality, like shade the part with the circle and all those. This is the imaginary part. Usually we use vertical to the imaginary axis line. So we still have 1, 2, 3, 4, but this is 1i, 2i, like that, and this is -1i, -2i, right? So if I want to graph -2 plus 3i, it's actually a point on this plane. It become a plane. So -2 is the real part, plus 3i would be here, right? So I graph it not as a point, but I graph it as -2 plus 3i. This is the point that represents that number. It used to be a number is on the number line, but if it is a complex number, it's on a plane. We call it complex plane. So don't mix it up with x and y axis. It's not x and y. So because complex number is, it's a number, so we want to do some arithmetic with it. How do we add two complex number together? How do we multiply, divide, and simplify complex number? So these are the key point on how to do them. If I want to add or subtract two complex number, I add the real part with the real part and the imaginary part with the imaginary part, kind of like combined like term idea. When I multiply two complex number, each one of them has a plus bi, right? A real part and imaginary part, so it's similar to a binomial kind of situation. So I use FOIL. After you FOIL, you may have some I square in the answer. You will simplify I square as -1 because this is the definition of the imaginary unit. How do I do divide? I do divide by multiplying complex conjugate of the divisor to the numerator and denominator. So when we talk about this, I'll do an example on this, and I'll expand on what is a complex conjugate. So let's do a subtracting and adding complex number first. So when we subtract complex number, remember don't just write -5 minus 2i. 5 minus 2i is a complex number, so you always parenthesis it. Okay, so but if you're doing subtraction, you would have to distribute the -1 just like when you are subtracting a polynomial. You have to make sure that you have all the positive, negative figure out. -5, but -1 times -2 is plus 2i, and then plus 8i. So I'm subtracting one complex number and adding another one. So it's just like combined like terms. So 3 and -5 are the real part. So I combine them. So this will be -2. Imaginary part with imaginary part. So 7i plus 2i plus 8i. So these are plus 17i. Oh, at the end, I have a complex number. A plus bi, right? So let's do multiply. I have two multiplication here and then add them. So this is one multiplication where I have just the imaginary part multiply into a complex number. And in this one, I have a complex number of a conjugate, what we call complex conjugate. What is a complex conjugate? Complex conjugate is when the real part is the same, but the I parts are opposite with opposite coefficient. Kind of like the radical conjugate, right? So complex conjugate, if I have 2 plus I, 2 minus I is a complex conjugate. If I have 3 minus 4i, the complex conjugate is what? Same real, but opposite coefficient of the imaginary part. So these are called complex conjugate. If you multiply complex conjugate, you will have no I left over. So let's try. Because conjugates, when they conjugate multiplies together, they're difference of square, right? So this would be 3 square minus 4i's, the whole thing square. That is, if you don't believe that your I part actually would cancel, so you will end up have 12i and minus 12i, so you don't have to do it. So minus 16i squared, but I squared is negative 1, so become 9 plus 16 is equal to 25. You see, no I, no more imaginary. So whenever you multiply complex conjugate, that's what happened. So let's try this, but these are not complex conjugate, so you just do, distribute or FOIL. So this would become 28i plus 8i squared. Remember, if you do multiply I and I is I squared. Plus, this is a complex conjugate multiplied together. It becomes 4 minus I squared, right? Square A plus B, A minus B is equal to A squared minus B squared. So let's replace all the I squared by negative 1 minus 8 plus 4 plus 1, because I squared is negative 1 minus I squared become 1. So I end up having 28i minus 4 plus 1 is minus 3. We write it is equal to negative 3 plus 28i. Okay, so that is multiplying. We want to do dividing. Okay, so but I think I'm going to do it in the second video after this. So in the second video, I'll do dividing, complex number, also use complex conjugate, and I will do an exponent of complex number also, okay, in the next